David Smith here with another flipped classroom math video. A few tips before we start. Remember that you can speed up or slow down the playback if that helps you follow along. You can also pause the video at any point to catch up with your notes or to try the problems before I explain. Lastly, you can turn on the captions and follow along with my words on the bottom of your screen. Okay, today's topic, the unit circle. This is a fundamental concept that relates to trigonometric functions, and it's also a really powerful, valuable tool that you can use to figure out problems. So we're going to spend some time just looking at the basics of the unit circle, and then we'll do some problems. Okay, so the unit circle is just simply this, a circle that's centered on the origin, which means the center of the circle is at the point 0, 0, and it has a radius of 1. Pretty simple thing, right? Here I am. Y and the x-axis, centered on the origin, radius equals 1. There's theta. We have an arc where we've rotated just a little ways around the circle. Remember, this is positive direction, counterclockwise. We've come up theta, and where this line that's described by theta hits the outside, we're calling that point P. And here's the cool thing. The coordinates of P are just cosine theta, sine theta. Whoa, cool. Where did that come from? Pretty straightforward. Let's drop a little vertical down here. Here's my x value. That's the distance I've come this way for that point. And here's the y value. That's the distance I've come up from the y-axis to get to that same point P. So let's write a trigonometric equation, a SOHCAHTOA equation, basic trigonometry for x. So I know the hypotenuse, that's 1. And I'm looking to find the adjacent side to theta. So cosine theta equals adjacent over hypotenuse equals x over 1, which is just x. So cosine theta is x. It works the same for sine or for y. Now if I want to find y, I'm going to use opposite of theta over hypotenuse. So sine theta is going to be y over 1, which is just y. So that's where this comes from. The y term, the y coordinate of the point P is sine theta. Now there's one thing that happens. If you tend to switch things, it's easy to think this is sine theta, cosine theta, but it's a little bit backwards. Remember, SOHCAHTOA starts with sine, goes to cosine, goes to tangent. This starts with cosine and goes to sine. So you'll need to remember that to get these problems right. Okay, here's a sample of a type of problem you might get connected to this lesson. Use a unit circle to show values for cosine of 270 and sine of 270. Okay, so it starts off by saying use a unit circle, so let's draw one. It's my x and my y. Now, we need to look at what 270 is. 270 is 3 multiples of 90. So we go 90, 180, 270. So 270 is right down there. So I can write theta equals 270 degrees. Okay? So now we want to find the values of cosine 270 and sine of 270. So to do that, we have to talk about what is this point? Well, we're on a unit circle. So this point is the x-coordinate. It isn't negative or positive. X is just 0. And the y-coordinate, we're 1 below the x-axis. So that's minus 1. So that's the coordinates of that point. Okay? So now we can answer this question. What's the value of cosine 270? Cosine 270, that's the first one. That's 0. And sine of 270, that's negative 1. Now, if you want to check, you can just plug those into your calculator and hit the buttons, and it should give you those same values. Okay, another type of problem you might get will look like this. Find the coordinates of P. Now they're giving you the unit circle, and they're asking you to figure out what P is. So for this first one, our theta is 300, so we've gone all the way around past 270 to 300 degrees, and here's our P that's out there. So P is going to be cosine 300, comma, sine 300. Now this kind of a problem you need to get out your calculator for, and what we get here is 0.5 minus 0.86. So those are the coordinates of P here on this unit circle. Try this one. Got another P, it's up here in the second quadrant with a theta of 152. See if you can find that. Okay, so the first step is that plug-in. P is going to be cosine 152 sine 152, which is going to give us, on the calculator, minus 0.88 and 0.46. Now, when you do these types of problems, just in case your brain does a little switch or doesn't quite work right, you want to take a look and make sure it makes sense, okay? So the x-coordinate in this position is positive, it's 0.5. That makes sense because we are to the right of the y-axis, so this should be positive. And the y-coordinate is negative, and that's correct because we're below the x-axis, so y is negative below the x-axis. So that makes sense. This one the same way. The x-coordinate is negative, so it means we need to be the left of the y-axis. Indeed, we are at point P, and the y-coordinate is positive. We need to be above the x-axis, and indeed, we are here with 0.46. Okay, now let's talk about tangent and the unit circle. And this is pretty straightforward. It's going to set us up for some trigonometric identities that we're going to work on a little bit later, like 4 or 5 lessons from now. So let's take a peek. Here's my unit circle, theta, point P. So, as you recall, we can drop this vertical down here from P, and we know that this is x and that is y, and we know that x is also cosine theta and y is sine theta. This is what we just looked at. Now, check this out. What's tangent of theta? If you remember from your SOHCAHTOA, tangent is opposite over adjacent. So tan theta is y over x from our diagram here, but now we can substitute in our value, our sine and our cosine. So tangent is sine, whoops, that's an O. Tangent is sine theta over cosine theta. Okay, so that's just kind of a definition here, but when you have an angle, this works. Tan theta is sine over cosine of theta. Okay? Okay, in this last bit, we're going to talk about the sign, S-I-G-N, positive or negative, of cosine, sine, and tangent for a given theta. So here's an example problem you might get. Find the sine, S-I-G-N, of sine, cosine, and tangent when theta is 320 degrees. So first thing you want to do, pop out your unit circle and figure out where that is, where 320 degrees puts us. And we know we're 90 to there, 180 to there, 270 to there, so 320 degrees is going to be 50 more degrees along. It's going to probably be about there. There's our point P, and we've gone around like that, 320 degrees. Okay, so now we're ready to answer the question. Cosine 320 is what? Cosine is the y value. When we're at P, y is negative. How about sine of 320? So sine is the x value. So what's the x value at P? It's positive. We are to the right of the y-axis, so that's positive. And tan 320 is going to be, from the last board we did, remember tangent is the same as sine over cosine for theta. So we're going to take sine and divide it by cosine. So we know sine is positive, cosine is negative. A positive divided by a negative is negative. So this one's also negative. Okay, let's have you try one of these. Here's your unit circle. Here's your theta. This time we're doing 140 degrees. And what you want to do is find the sine, positive or minus, of cosine, sine, and tangent for 140. So go ahead and pause the video and give that a shot. Okay, let's see how you did. So, cosine. Cosine is the x-coordinate. Let's actually cut. Crap. Okay. Action. Okay, so let's give you one to try. Here's my unit circle. Find the sine, S-I-G-N, positive or minus, of cosine, sine, and tangent for theta equals 140. So go ahead and pause the video and give that a shot. Okay, let's see how you did. First off, let's put our 140 theta in here. 90, 180 is all the way back around to here. So it's somewhere up here in the second quadrant. Here's our theta, 140 degrees. And here's our point P. And let's do a label here just to make this super clear. Remember that x is cosine theta, y is sine theta. So that's P. Cosine is the x-coordinate, sine is the y-coordinate. This is helpful for that. Okay, so what is the sine of cosine? The S-I-G-N of cosine. Cosine is the x-coordinate. So when we're over here in the second quadrant, the x-coordinate is negative. So cosine would be negative. Sine theta. Now sine theta is the y-coordinate, and you notice we're above the x-axis. In the second quadrant, y is positive. And now we know that tan theta is negative because we have a negative divided by a positive according to that trig identity. Now there's another way to do that. Tangent is the slope of this radius, because that's just rise over run, which is sine over cosine. So you can look at the slope here and you can see that's a negative slope, so tangent has to be negative. That's just another way in to figuring out whether tangent is positive or negative. Now that you've finished, take a moment to write down any questions so you can bring them to our next class and get some help. You can also watch the video again to improve your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.